So usually refractive telescopes will use in normal mode. No? So let me, this one. So this will be the one convex lens. There's a mirror. Okay, light coming from far away object. Anywhere, I can adjust it anywhere. Two different colors will take it, red and this one. Again, check the mains paper. We don't have much, no discussion on much or no questions on the reflective telescope. Possibility of asking. You have to put effort in trying to understand and learn it. There'll be some objective lens. Okay, light after passing through this, and here the eye will be there. Okay, fine. Diagram. Yeah, okay, no. You can see this. What we should do is like, this is the reflecting concave mirror, and this will become F0 and this will become eyepiece. The convex mirror is of just only for one purpose we have brought it, to send the rays back towards the eye lens. This is a convex mirror. So what is the constructions we have to take care now? So there's a convex mirror. The light coming from far away object, okay, after getting reflected, so they will try to be at focal length of this one. So then what will happen? I'll bring a convex, that one. And what it will do, it will make the rays to fall at certain point. What is F0? F0 should have been this one, no? Am I right? According to the, because after reflection, they'll try to meet at this point. So this will be the F0. Now here what we do is like the convex mirror will make them to bend like this. So it will be, so now it will get diverted. You can see this one. So here if I make FE, so again what will happen? The rays after refraction will become parallel. So this point you can write it as FE. Wherever you want, you can adjust this FE, because this is mobile. I can move this one. This FE you can bring it here or here, wherever the focus of this eyepiece lens, you can bring it really wherever you want. and finally I'll get the image form. Now you see that what actually happens here, the object which is far away, the rays incident by it open will be gathered by reflecting surface. We know it is a reflector, and due to reflection, loss of light will be negligible. So what will happen? The maximum information of the incident rays will be gathered by that. And we know the resolving power depends upon the intensity of light. So the resolving power will be increased. That's the one thing. Next, again, the focal length of this reflecting mirror. How to bring the reflecting component? I'll just take some steel now. I will do smooth finishing on this inner surface. And the steel, what happened? Thin, flexible steel. I can construct this reflecting surface of height of the diameter 10 meter, 20 meter, 30 meter. And I can easily rotate also. Glass, very difficult maintenance. This will be much easier. Mounting everything. So this is the advantage of reflecting telescope. I think if you check the in websites, no, reflecting Newtonian, this called as Newtonian telescopes or reflecting telescope, 5,000 rupees. Above that, it will start. You watch the images in that one, no, good clarity you can see. Ordinary 3,000 rupees you buy astronomical telescope. That what happen? The image what happen will be blurred, will not that much of clarity. The reflecting telescopes are widely used for astronomical purpose, not terrestrial purpose. Of course, you can use for terrestrial also, but it is widely used for astronomical. More than 5,000 rupees if you spend now, you'll get reflecting telescope, basic model, very good. You can see the rings of Saturn clearly. You can enjoy the sky. I'm telling this one, more beautiful world is there if you have a telescope. More beautiful world. So afterwards, if you get into IITs, NITs, no, instead of purchasing one pair of good dress, no, nowadays I think 3,000, 4,000 rupees dress is there. Purchase one telescope. You can enjoy things. Huh? What about the magnifying power? The same formulas, nothing will change. For near point M25, I think these are the formulas what we were using. F naught. One plus, I think I remember FE by D. Yeah. For 4 point, if the image is at 4 point, it will be F naught by FE. This is called as normal adjustment. The same formulas, everything. Only thing is the objective lens is replaced with a reflecting concave mirror. They may trouble you. So where do see whenever what will be the heavenly object, the distance will be infinity. Where do this image I1 will be found by this? It will be I1. Okay, got this one. There's a convex mirror. If image is formed at I1, after reflection, it will form the real image somewhere I2. Then this I2 will become object for this and will get I3. They may trouble you question of like this. This will form image at this particular point. Say that this will be I1. Convex mirror, what happens? This I1 will become object for convex mirror. It will form image I2 here or here or here. That I2 will become image for this. It will form I3. If you want, you can go for ray diagram of that also. That's why I'm not showing the rays parallel. Now, can you move this as you can move this convex lens? You can move. So if you adjust this, and if it is at focal length, anything will happen. After reflection, if this is the focal length of convex mirror, then in that case, what happens? This rays will become parallel, no? This rays will become parallel. After refraction, what will happen to these rays? Will be focused at this particular point. But we want, what should be the adjustment? The ray should enter parallelly into the eyes. Then only the eye will be relaxed. So therefore, the after reflection from the convex mirror, the rays should not become parallel. Keep in mind. Because the rays, if they enter eye normally, then the image is said to be at infinity. Am I right? So that's why I took the diagram like this. In the books, what happened, they have shown this to be parallel, and afterwards they're telling, but this should be the correct one. They may test you with the diagram also. Now, where is the final image? Final image is at infinity because the rays are incident parallel. The rays are entering parallel into the eye. Final image is at infinity only. Okay, this is about the reflecting. Any questions, conceptual questions, anything can be asked. So, but anything numerical, no. So you can just take help of this concept. Okay, let me go for the damped oscillation. I will give separator because even for recording also will